Yes, guys, I hope the voice is clear.
Yes, sir.
So, did you get the link?
Yes, sir. Yes, sir.
Yeah, so just I'm taking the question first. Let me take the entire question so that the others can understand. The question is the mass, comma, radius and length of a wire are the mass, comma, radius and length of a wire are zero point 0.3 grams, zero point 0.3 gram, comma, zero point 0.5 mm, 0.5 mm and 6 centimeters respectively, full stop. The maximum possible errors, the maximum possible, the maximum possible errors in them, are 0.003 gram, comma, 0.005 mm, 0.003 gram, comma, 0.005 millimeter and 0.6 centimeters respectively, right? Then the maximum percentage error, the maximum percentage the maximum percentage error in the measurement of in the measurement of density of the wire, density of the wire will be, right? Options are given as first option 1, second option 1.5, third option I can take it as options as ABCs, option A, option B, option C, yeah, 3, option D, 4, right? So how to do this? You have to understand that first. Actually within 1 minute you can do it, but for understanding, let me give you clearly step by step. So it is given that, given, if you see in the question, yeah, mass, radius and length of the wire, m, mass, radius and length. Quickly you can note down. There 0.3, 0.56 in CGS units, 0.3, 0.5 and 6.3 gram, 0.5 millimeters and 0.6 centimeters, right? The actually the values of mass, radius and length of a given conduit, so we can express them in SI system also for calculation purpose. We can write it as 0.3 into 10 to the power minus 3 kilograms. If required, you can use, otherwise you can use this values itself, no problem, but depending on the requirement. So and R is 0.5 into 10 to the power minus 3 meters, and L is equal to 6 10 to the power minus 2 meters. And it is also given that the maximum possible errors in them. So maximum possible error in mass can be expressed as delta m, and in radius as delta r, and in length as delta l, are given as 0.003, 005, and 0.6. 0.003 gram. This is 0.005 mm. This is 0.6 centimeter. Okay, right. Anyway, just if depending on the requirement, the same units of grams, mm, and centimeters also you can use while calculating the errors, maybe fraction error or relative error. Now the question is the maximum percentage error in measurement of density will be maximum percentage error in measurement of density. Density is denoted by the symbol rho. Delta rho by rho is into 100. This is fractional error or relative error, into 100 gives percentage error, is equal to what is the question. So here you have to write the formula for density. We know that density rho is equal to mass by volume. Density rho is equal to mass m by volume capital V. So this in terms of formula, we can express it as rho is equal to m by v. This implies rho is equal to m by v. Mass is given and error in mass is given, but volume is not given. Some other terms like radius and length are given. So there is a wire. This is a wire having some mass. Is given that this is a wire having mass and radius. Radius is given, means that's a cross-sectional cross-section should be circular cross-section. So this is radius, and length is also given. Length is given. So then from this given data, you can understand that volume is equal to, it is in the form of a cylindrical shape. For a cylinder, volume is nothing but, if this is circular cross-section, area of the cylinder into the height or length of the cylinder. Because it is circular, having circular cross section, area is pi r square into L, gives volume V. This you have to substitute here. Then you can get m by pi r square. L is density. Okay. Now, what you are asked to find the percentage error in rho. So first you have to write a relative or fractional error in rho. Fractional error in rho can be expressed as delta rho by rho is equal to fractional error in m, delta m by m, plus fractional error power times fractional error in r. Pi is a constant, leave it. So 2 times fractional error in r, delta r by r, plus fractional error in L, delta L by L you have to take. This gives fractional error. Right. Now, there in the given data, M, R, L are given, delta M, delta R, delta L also given. If you see those values, you have to substitute here with the same units, so that units may get cancelled. So then you can write, this is, if this is a relative error, if you want percentage error, you have to multiply this with 100. So into 100 gives percentage error in rho. So this into 100 gives percentage error in this, into 100 gives percentage error in this, into 100 gives percentage error in this. Or first calculate the fractional error, complete fractional error in all the three. Then you can multiply. At the end you can multiply with 100 also, no problem. Okay, for convenience, let us do this way. So this is equal to delta m by m. Delta m is how much? Note down from the above given data. Delta m is, yes, this is delta m 0.003 gram, m is 0.3 gram, 0.003 gram by 3 gram by mass is 0.3 gram. 0.3 gram. So gram cancels anyway, no problem. Plus 2 into delta R by R. Delta R is 0.005, R is 0.5. 0.005 by 0.5 plus delta L is 0.6. L is 6 centimeters only they have given. Now on simplifying this, you will get what you will get. Just if you can write it as 3 cancels, 0.1 will be here, 5 cancels, 0.1 will be here, 6 cancels. On simplifying further, you can also write just if you multiply the here 10 by 10, 10 by 10, like 10 by here no need, depending on the requirement you can just write simplify it by multiplying 10 by 10 for this term. Then you will get 0.0 is 1 plus this becomes 2 into 2 into 0.01 plus this is 0.1 anyway. So it gives 0.01, 0.01 into 2 is 0.02 plus 0.1. It gives 0.1, 2 plus 1, 3, 0.13 is delta rho by rho. Yes. This gives fractional error in density. Fractional error in density approximately. So here into 100, 1 second, the maximum percentage error in measurement of density will be, the units of the quantities are same only, right? How to cross check the that if you have taken any values differently or not. Volume is area into L pi r square L. Yes, correct only. So on simplifying this further, yeah, just cross check once the data which is given. Yes. Now this is okay. Oh, this is as we know we need the percentage error, right? Percentage error means you have to multiply with 100. So now here at this step, if you just multiply with 100, you will get this is 1 plus this becomes 2. This may become 1 second, Nana. Yeah, tell me. Are you getting my voice? Tell me. Yeah, hello. Yeah, are you getting my voice? Yes, man. Tell now. Yeah, yeah. Pi r square L only. Check pi r square L only. Volume is area into length pi r square L. I think there on a small. Yeah, actually here this I think we have taken some small mistake in change in length. Change in length is delta L is not 0.6 centimeters. It is supposed to be 0.06. Okay. If it is 0.6, then I think the answers as per the options you will not get much. So I think then there will be a mistake in the question. If it is 0.6, then you will get 10 here. Okay, then you will get 10, 12, 13. You will get 13 percentage. But in the options, you see, no such option is there, right? So actually, it is supposed to be 0.06. If it is 0.06, this is 0.06, then you'll get here 0.01 into 100 gives you 1. So this gives you 1. Then you'll get instead of 13, 4% you'll get. That is the I think printing mistake maybe. So total maximum percentage irradiant density is delta rho by rho into 100 is equal to 4%. So if it is 0.6, then you will get 13%. If that is okay, means then options in the options you should have 13%. Then only the question is correct. Otherwise, just you have to take a correction. Yes, this is what you have to keep in mind. In the question, I think here we have to take this correction. It is supposed to be 0.06 centimeters. It is supposed to be 0.06 centimeters. If you take that, then you will get properly this one. If it is not the as per this what do you call options, it is supposed to be this, right? Okay, try to go through once again.